Before I forget, let me go ahead and swap over to the main playlist. There we go. Whoa. That is a downgrade. That's even worse. Yeah, screw it, I'll take it. Anyway, let's go ahead and get started. So what I have is the Sgl Programmers tutorial. If you want to follow along with me, you can go to Antime's website. Let me see if I can get a page number on the bottom of this thing. There we go. 13, 14, that makes this 15. So if we go over to, let me see if we can, Chrome. Oh, okay. Where's Antime? There we go. I own stuff. Saturn Development Central. That sounds right. Well, wasn't that one? There we go. Okay. So if we look through this stuff, there's a couple things that you want to grab if you want to follow along, and I will link the relevant documentation in chat. First off, you're going to want the Sega Graphics Library Developer's Manual reference to be able to look up, and the manual tutorial, which is what we'll be using tonight to learn. On top of that, there should be Sgl Libraries. So that's what you want to grab as well. And these should contain all the samples already pre-made that require some minimal adjustment to be able to use on the modern setup. So what I'm using is an upgraded version of what's available on my website. Go to, let me see, emeraldnova.com, code, so Sgl Hello World example with compilation environment for Windows 64-bit. This is the version that I stripped down from XL2 in his Sonic Z Dream code. Fafling has been kind enough to try to strip it down a little bit more, make it more efficient, and he's currently working on something I can release here. In the meantime, what I have here would work well enough, and I should have in the near future something I can update for that. Okay, now let's actually get started. So we're going to see how much of this game programmer's tutorial I can get through while I still have a supply of caffeine next to me. Let's see. This chapter explains the procedure for software development. Now, a lot of this is no longer relevant. This is like the original programming setup that you would have followed using the development tools available in 1994 and 1995. What we have is just a compilation environment using a modern version of GCC and emulation. So this is much more simplified. And for those that are so inclined, you can use the USB dev cart, which Cafe Alpha sells on his website. And as long as your program is of appropriate size, it will send through USB to your Sega Saturn via the cart slot the program to run. And with a little bit of setup, you can get that going, and this would be the most similar environment and also a pure hardware test. I prefer working in Mendefend because it's just faster and less of a headache. So we can skip all that stuff, this stuff. The Sgl makefile, we don't really mess with until we have to, so we will leave that alone. Debugging is for people who know what they're doing, and I don't, so we're not doing that. Okay, loading, executing, that comes with just running the Mendefend script. Debugging, like I said, don't do that here. Okay, values in the library. Okay, so here's some good notes that you want to keep in mind. Floating point decimals are not supported in Sgl. Technically, at least within the Joe Engine framework, you can use them. They're just not accelerated by hardware in any way. They're exceedingly slow, and there's no good reason to use them. You should get used to using fixed And they explain that there's 16 plus 16 bits. First 16 is integer, last 16 is decimal. So I have an article on my website that kind of explains this in a little bit more depth than 2 sentences, but that is what it is. Angles, also something of interest, is 16-bit that rolls over into itself, just like you would on the angle. When you get to 360, you get back to 0. Except the expression for 360 is the maxed unsigned value of a 16-bit integer. So you can see just the hexadecimal representation that they show here. Moving on. Matrix values. So we have the matrix type, which gives you a 4x3. The matrix part that is relevant is the 3x3. I am not super certain what the final row does. Let's just read this a little bit more closely to check. Table below, let's... Okay, well, I'm sure when we get to actually using them, they will explain if we need to mess with this bottom row, what it does, or what the point is. Now, this toFixed allows us to input a floating point, and at compile time, they will convert it to the correct number, unless you are actually putting in floating points in your program, which, as a bad habit, a lot of Joe Engine samples do, in which case I'm certain that this is a lot slower than what I just said. And even then, toFixed, I don't know if it's like actually optimized so that at compile time it would know to do that. But even still, if you're only doing it once, like you're just initializing values in memory, I don't think there's any harm done. Still, though, you should get into the habit of just learning to express things in terms of fixed. Degree to angle, similar situation. You should just kind of learn to do this on your own. So here, in this case, P times bliss times 0. Okay. Yeah, so this is just multiplying by, this is the value for 1 in fixed, and this is the value for 1, or the maxed 16-bit value that you can get in terms of angles. So remember that 360 is the same as 0 is the same as the maximum value, or the 1 plus the maximum value of a 16-bit integer, which is this number. And they're dividing it out by 360, so it evenly divides into the angles that you need. 8D. I don't know why 8 is in there. Degree type. This may or may not be a typo. In fact, that's almost certainly a typo. I would not put the 8 there. But I'm pretty sure the actual implementation is correct. Position toFixed. This one feels a little bit self-explanatory. You take a 3-unit vector, and then you turn it into 3 fixeds. I don't think I've ever actually bothered using that. Okay, so here is the canonical coordinate system for Sgl whenever you're talking about what's going on. So by default, before you transform anything, X is to your right, Y is down, and Z is forward into the screen. And if you're talking about 2D coordinates, you just take away the Z component, X is right, Y is down. Keep that in mind. Okay, now we actually get to start doing stuff. So they're talking about how polygons are formed. This is just a theoretical concept of a polygon. We don't actually have 8 vertex polygons in Sgl. Everything's going to be done with 4 vertex polygons, or effectively 3 vertices where it's just an extra vertex is on top of the previous one. There, see, just like I said, V3 equal V4. That's just how you make a triangle. It starts the draw going from V1 to V2 to V3/V4, and then it loops back to V1. You know, just basically in order, as you'd expect. And I'm guessing this is telling us also if, in the case of backface culling or single-sided drawing, what order we expect to be facing the polygon when we were drawing it. So If you are drawing a polygon on screen and you're only drawing one face, so it only draws in one orientation versus the other, make sure it's drawn in this order. So that's more or less something that we'd only have to worry about if we're manually creating our own polygons. Generally, what we'll be doing is we'll be making stuff in Blender and having an exporter tool like XL2 ZTream or ZTP converter, and that should take care of that kind of stuff for us. But of course, that didn't exist in 1994, so whoever is reading this document in 1994 is a developer that has to make his own tools, more or less from scratch. So he is going to have to keep this in mind. So there we go. We need a list of coordinates, the point table essentially for vertex, list of faces of the polygon. So this is for multiple polygons. So one polygon should have one face to my knowledge. Determine the surface attributes for each polygon face. So, yep. Essentially how it's going to be drawn. And then you put SL put polygon to draw the actual polygon on screen. Oh, there it is. SL put polygon. And this is a command you see all the way, you know, basically everyone that's doing 3D is going to do this. Knights uses this. Hellslave uses this. I don't know anyone that's actually making draw commands without saying SL put polygon at some point. And the P data is just a collection of all the data that we need to describe the collection of faces. So you'd have a P data that has like a point table. So all of the vertices relevant to the mesh being a collection of all the polygons being drawn, all the faces with all the texture IDs, and the textures themselves should be loaded in VRAM somewhere. And now we come to our first sample that we can now run. Now, if you are following along with the Antime sourced Sgl, you will get a bunch of sample programs that look kind of like this. Now, essentially, here, let me go ahead and wipe it out so we can just see exactly what we need. Essentially, all we're going to retain is the C files. For safety's sake, because of my environment, I'm going to put everything in lowercase. Now, I swear I was playing with this before. Okay, yeah, so S22. Okay, there we go. So now we have polygon.c, main.c. What you're going to want to do is from a working environment, there's a few things that we need because we are still kind of inheriting some tools from GeoEngine, the way we're doing stuff. We're inheriting an ISO maker. So we are going to want to lay things out in a way that allows us to manipulate what we need and put the files on the CD block as needed. This is slightly different than what was happening before, but this is the tools that are available today, so we need to format the old code into the new way of compiling disk images. So the first thing we're going to do is I'm going to take the make file that I know works, and from the, from the Sgl instance that works. In this case, you would be going to, if you have nothing, emeraldnova.com and downloading this to get this working environment with a Hello World program, and you're going to go into the project folder and go the one project there should just be a Hello World. In fact, it should look like this, something like this, Hello World. There we go. And we're going to steal from it the batch scripts so that we can clean, compile, run, and send to Mendefend. We're going to steal the make file, and we're going to steal common.h, the CD folder, and ZTE. And the ZTE is holding the work area, so I'm going to copy that all in. So the CD folder is empty, but we need it because that's how we're building our CD image. All the files that should be loaded onto the CD on the disk as like files that you can browse would be going in there. ZTE contains workarea.c. Now, workarea.c lays out the work area for Sgl, and this defines how all of our RAM is going to be set up. So this works together with common.h, which we also copied over from the working project folder that's been prepared for us. And we see things like, oh, here's the max number of vertices, max number of polygons that we have set up. This is actually a value, I believe, that's different from default, and we'll see that if we haven't already somewhere in the document. And so this essentially just sets up our entire memory map for how we're going to play with Sgl and where Sgl is going to put stuff. And so if you're working on a game that requires fewer vertices, fewer polygons, and you want to use a high work rand for something else, you can lower this number. If you feel like you want to put a lot of quads on screen, you raise this number and this number accordingly. And then also this area tells you where stuff is going to go. So as far as I can tell, Sgl work area is going to define where a lot of our initialized variables are going to end up. Master stack, slave stack, system work starts here. Okay, system variable. And then if Knight of Dragon makes his way on tonight, he can tell me if my memory is set up in a way that is compatible with the Netlink OS update that he is working on. That's okay, Pona. I appreciate you squatting on here anyway. This is probably all stuff you'd know anyway, so I don't think you get anything out of it. Anyway, so let's go ahead and start actually opening up the files that we got. So there's polygon.c, and this is essentially defining the polygon, and then there's main.c. So in main.c, because we are taking these ancient files from different kinds of computer systems and we're trying to convert it to something that's usable for us today, there's a few things we need to fix. First, you see this sub character. I'm seeing this because I'm in Notepad++. I don't know if you're in a different IDE. Yeah, so once I get to attributes, I may or may not want to poke at you, but like, you know, feel free to drop in or out as you get bored. This is mostly for the benefit of just looking through the Sgl tutorials, because there's a lot of stuff it goes through pretty quickly and pretty effectively. Anyway, as we are transferring over these ancient 1994, 1995 C files into a modern system on Windows 64-bit, using, I'm guessing, a different encoding from a different system, going from Japan to America, going from, you know, whatever Windows 95 was using for their IDEs for whatever I'm using now, we have to change a few things. First off, we don't compile void ss_main. We compile int main. So your main function needs to be changed to do that. Everything else is in terms of Sgl and should work just fine. This sub character is this file terminating character that is no longer compatible with how we do things, so we erase it, but we always make sure that we have some blank space at the end of the file because it's expecting that. Polygon.c, no changes required, working just fine. I do want to note that if we look at this, going back to the discussion earlier about what order the vertices need to be laid out to draw something that's facing you. Here we have -10, -10. That's going to be top left corner. And then 10, -10, it's top right. And then 10, 10, because negative to positive on Y is going down. So that's bottom right corner. And then -10, 10 is bottom left corner. So we're going in that clockwise motion that was described here. All right. Polygon, the normal. We need to define normals and we need to find vertices. So we have a point plane here, and this is just defining, this is just a table of vertices. We are defining a polygon with the vertices in this order, 0, 1, 2, 3. So every polygon needs to be made up of some 4 vertices. We're telling it which 4 vertices to use. If we wanted to make a triangle, I suspect we can change this back to a 2. And it would do what we need. The normal, this is the normal, I don't really understand, because if this is in terms of X, Y, and Z, then the normal appears to be in the Y direction. So first off, let's go ahead and just compile and run. So for me, using the setup that I have provided, we will have clean, compile, and run with Mendefin. I don't know if the distribution is slightly different for what's on the website, but essentially I have debug Mendefin, which just runs clean, compile, and run with Mendefin. So what that does, clean, it cleans out any previous compilation files. Compile does what it says, compiles the program into a disk image that's runnable on a Sega Saturn. And then run with Mendefin, takes that disk image, runs it. So let's run it. Ah, there we go. Undefined reference to PD plane. What did we forget to do? We forgot to go into our makefile and add to our sources polygon.c. Okay, so we have drawn just a plain old blank polygon white on screen, and then we've also printed some text on the top of the screen. So when we look at our program, we got an angle and a position. The angle is 0 degrees. We have initialized our system to 320 by 224. That's like the standard default Saturn resolution before you start doing anything fancy, like making high resolution interlace or whatever images. I'd have to go into SL init system under the reference to figure out what this all means, but for now, this is boilerplate. This is how you initialize a system. Let's see. We're putting 0, 0 should put things at the center of the screen, left, right, up, and down, and then 220 puts it 220 units in front of us, so that in terms of perspective, we can actually see something without getting near clipped. There's the sample program that we printed at the top of the screen on line 9. Oh, sorry, line 2, 9 characters in. While -1 is an infinite loop. Push matrix basically wipes out any previous rotations or transformations that you have in the matrix buffer that we're using to transform this kind of stuff. Essentially, you need to if you're going to move any sort of polygon inside the program, you need to transform it using matrix multiplication, because everything is going to be multiplying vertices and normals by this transformation matrix. So we have translate in terms of position, rotate along X, 0 degrees, rotate along Y, 0 degrees, rotate along Z, 0 degrees. I did not know you could do this in C, but now that I do, I'm going to use it all the time. In fact, I don't know why this didn't do that. SL put polygon, like I said, anytime you draw, you do that. Pop matrix should essentially wipe out. So I misspoke. This is to give yourself the space to start playing with matrices. This wipes out what you just did. So this puts a matrix onto the stack that you can start manipulating that starts with identity matrix, no transformation. And whatever you just did disappears after you pop. SL sync, I believe, is more boilerplate, where we wait for essentially the V blank when the screen starts drawing to continue operating the program. Now going back here, we have this normal that's pointed along Y, and that's weird to me because we're not rotating anything. So this is telling me the normal is going down as opposed to toward the screen. Now, is this correct? I don't know. Let's find out. So that didn't seem to break anything. Now, am I about to say that Sega was incorrect for putting their normal where it was, or is the normal even being used for anything right now? So right now we're in dual plane mode. So I'm getting ahead of myself, but dual plane mode means that no matter what perspective we're looking at, we're drawing what we're drawing. So in this case, the normal is not really being used for any sort of sorting mechanism. Let us, in this case, switch over to single plane mode. So I have the developer's manual open. Let me go and... here, I'm gonna go find my... It's off somewhere where I don't need to look at too much. Game dev documents, Saturn reference stuff, Sgl reference. There we go. This is the other thing I told you to download earlier, and it's for this kind of reason. So we got, well, first off, let's make it so we can actually read what we're seeing. Let's look for dual plane. There we go. Let's try instead Sgl without an E plane mode. Sgl. Okay. Oh, undeclared here. Interesting. Do I need to type it in a specific way? This looks like this looks correct. Okay, this is where I start bugging Ponut for help, because the thing that's supposed to work here is not working here. Clean. Maybe it needs the E? Maybe it is Sgl with an E plane mode? I am not a fan of this song. Okay, that's off the playlist. Yeah, I'm not doing that one either. Hey, where is shuffle? No, this is supposed to be random. What are you doing? Okay, I'll take it. Let's try Sgl with an E and see if there is, if that's just an Sgl typo. It's an Sgl typo. So, Sgl's documentation, at least in our community, is famously filled with typos and incorrect items, and this is among one of them. Okay, so normal, as far as I can tell, is pointed directly down to the screen. Now, let us try to make it point away from us. So positive normal along Z should be facing away from us, and that means the thing, the quad should not be drawn, as far as I can tell. I might be wrong. Oh, there you go. Now, if we put a minus sign so that it's facing toward the screen, what does that then mean? Aha! So it worked exactly how I thought. So I believe that Y direction normal was incorrect. In fact, it should be -1 should be the normal, that so that it is facing directly toward the screen, because we have a flat plane here. So if you just the way to construct a normal, in theory, is to take a corner, let's say vertex 1, and you find the vector between 1 and 0, and then 1 and 2, and then you take the cross product of those two and normalize the normal. And by normalize, I mean make it so that the magnitude of it is 1. Magnitude being x squared plus y squared plus z squared square rooted. I mean, so when I say it out loud, it's a little bit harder to follow, but essentially, if you're playing with linear algebra, you already know how to do this. Okay, so we have single plane mode. Now, the other thing I wanted to try out is, can we make this a triangle? So I took away the bottom left corner and made it a repetition of the bottom right corner. So it should look like a triangle with, yep. I took away the bottom left corner, and now it's just a blank triangle. Now the other thing is, let's go ahead and square it out again. we are setting the color with this plane attribute. No texture. Weirdly enough, I didn't like the other boss music, but I like this boss music. I don't get it. Something's wrong with my ear. And let's make it green. As in emerald. Hey! Okay, cool. Well, I feel like we've gotten all we're going to get out of this program example, so let me just go ahead and reset it back to what it's supposed to be. And let me clean up this game folder. Clean. So all the .o files, all the whatever was in the CD block that was being built this. I'll show you. So let's compile real quick. Okay, so we have game.q, elf, ISO. I believe the Q and the ISO are what we need to actually run the thing, because the Q is just saying, hey, the game binary is under game.iso. Freaking heck. What is all these short jingles that are making it into this thing? Okay, there we go. So, what was I doing? Let's see, fix the normal, there's square vertices, it is indeed a square, no texture, CRPG, okay, we reset that. Oh, right, the files. Okay, so we got the Q, the ISO, these are the two that you want to run in your ODE or emulator of choice. I can't tell you for certain what an ELF is or what it's for, but I'm certain at some point it was useful for compiling the disk image. The disk image itself here is not even a megabyte. That's neat. We have the game map file. I believe this is also used during compilation. The O files are essentially C translated in machine code in order to be used for compilation. Then we look in the C folder. We have 0.bin, which is the game information on the CD block. Now, if someone was actually watching on stream, they'd be able to correct me on this, but I believe a lot of people are just kind of chilling. Whatever. Anyway, let's clean all that up in here. Okay, all gone. That's clean. And then ZTE is still whatever it was. Moving on. I find these flowcharts of limited usefulness, but maybe you'll find it a little bit more useful as you go through it. They included the mistake in here. Okay, neat. Yeah, but that is the drawing pattern, so, you know, when you take out the V3, make it V2, you turn it into a triangle. Just, there you go. Okay, so this is essentially telling you how to create a more complex set, because you have one vertex, one face, but you can create several. And then when you point to the P data of that collection of several faces, several vertices, they all get drawn by a cell-put polygon. You got your vertex list, you got your face list, and then you got the attributes for each face. It's an odd song, but I'll give it a chance. Okay. Maybe I should turn on word wrap or something. Make it a little bit easier to watch. So PD plane, where does that come into effect? PD plane 1. So PD plane 1 is the P data that we're pointing to draw, and it grabs the point table here. And this is size of point table divided by size of a single point. Tells you how many points are in the point table. Plane, this is the list of all the planes in our table. So the size of the plane table divided by the size of a single polygon tells you, or a single plane in this case, because the plane is a polygon. It tells you how many faces you're trying to draw, and then here is the attribute used to draw it. So this attribute is basically getting applied to the entire collection. Now, oh, sorry. I'm misspeaking because this attribute is a single attribute assigned to in the same order as the plane. So we have one plane here, one attribute set up over here. So we'll go forward and we'll see more examples of how this works with more planes involved. So there we go, combining multiple polygons. That's what sample 3.2 is about. So we're going to create a cube, or at least someone at Sega is going to create a cube, and we're just going to use it. I've already set up this sample for us. Let's see. So now, a cube, to uniquely identify all the points in it, should have 8 points total. So that's 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay, that checks out. 6 faces, 1, 2, 3, 4, 5, 6. And in turn, 6 attributes. 1, 2, 3, 4, 5, 6. So they're all getting assigned essentially the same drawing commands, but different colors. So the first plane is getting set as red plus green is yellow, and then red, and then green, and then blue, and then red and blue is purple, and then blue and green is, I should know this, like cyan or something. Hey, Knight! Welcome to the stream. I am literally going through all the Sgl samples in order. Well, we do not have a we do not have control over orientation, so we can only see 3 of them. So we see the purple, the green, and the blue. You do see this variation in lighting, and that's because we are playing with lighting in this example too. Let's see, the listing, vertices, PD plane. So none of this is new information. Let's skip ahead to the actual interesting part, the lighting. Or skip behind. Where are we going? This is sample 3.2, right? 3.2. So they're doing something with the lighting. Where are they doing it? I'll just look through the code and find it ourselves because they're not telling us. There we go. Sgl calc point to apply the light, and the light itself has a direction on the minus X direction. So pointing to the left. There's a light source to the right that's illuminating something. Sgl light. Oh, yeah, there it is right there. So why are they not telling us about it in here? Here's the polygon.c, but where is the sample.whatever? That's 2.2. So that's them constructing the cube. Distortion is caused by... Oh, they're just talking about just perspective. Yeah. Well, that's not really a problem. Oh, they skipped ahead, that's why. So they're saying, okay, here's how you make a cube. This is from sample 3.2. We're not actually going to talk about sample 3.2 yet. This is just how you make a cube that came from sample 3.2. Now we can go to chapter 3 where we can talk about sample 3.2. Light sources. Neat. Okay. Now, it was my previous bias that any time I played with light sources, while in the confines of Joe Engine working with ZTP, the things did not work out well. Will this continue if I just use Sgl with a possibly more updated version of ZTP? I don't know. Especially because I have a tendency to try and reuse entity models, which means lighting effects for one model gets translated for every copy of that model, which may or may not be what I'm trying to do. Okay, so light is defined by position, intensity, color, and presumably the position is also going to give you the direction unless it's just a point source. All right, okay, so if it's a point source as a position, if it's not a point source, I imagine it would be a direction, and that makes more sense. color of the polygon face is changed according to the angle of incidence of the light, and this is going to be modulated by the actual normal of each face. So the normal of each face actually needs to be defined correctly. Now, we saw in sample 2.2 that the normal was incorrectly defined, but is it going to be correctly defined here? 0, 1, 3, 2. Let's check that out. 0, 1. So we're going from minus z to plus z. So we're going from close to far. 3. Now we're going from minus y to y. So now we're going close, far, down. And then minus 15, and then back again. So if I am looking at this in the correct manner, close, far, down, back, presumably the normal should be facing the positive x direction. No, wait, sorry, right-hand rule. Okay, so that should be the negative x direction. So this looks like it checks out. I'm going to trust that everything else checks out because it's actually being lit correctly. So let's just go back to that drawing, and we use the right-hand rule. So for the right-hand rule, when you see something going clockwise, like, or sorry, yeah, clockwise like so, that means the normal should be pointing into the screen. Now, maybe I'm looking at this the wrong way and the normal needs to be opposing in order for it to make sense. So, let us take a normal that I know I'm looking at. Well, first off, let's make all these guys single plane. That would make it all single plane. And let's see, they are definitely rotating it because the faces are being rotated by... Oh, there we go. Y is temporary. Adding 1 degree every time? It's odd. Oh, no, that's for the light source. The light source is at 15 degrees for X and Z, and then Y is variable depending on what's going on. Angle 30, 45, 0. Okay, so that's a fixed angle there. So an X direction rotation is going to angle it downward. A Y direction rotation is going to rotate it around so we can see different faces. Okay, let's go ahead and give it a shot. See if I broke anything with single face because the normals are in the opposite direction that I expect them. Well, this didn't really tell me much, but let's see, which one is the blue face? That's the one we should be tracking. The blue face, as far as I can tell, is the one that should be facing us. So RGB, blue face is the fourth one. The fourth one should have the fourth normal here. Or sorry, 0, 1, 2, 3. So index 3 is the fourth one. 0, 1, 2, 3. Index 3. So yeah, this is the normal I expect for the front face. -1 facing us. But let's double check on the indices. So we have 4, 0, 1, 2, 3, 4. So we have positive x minus y minus z going to 0, which gives us minus x. So we're going from right to left. Close to the screen because we're at minus z. And then 0 to 2. 0 to 2. So now we're going positive y. So we're going right to left and then left down. And I suspect 2 to 6 is going to get us from lower left to lower right. 0, 1, 2, 3, 4, 5, 6. Yep, and then we move. Wait a minute. Sorry, 2 to 6. So yeah, we're going from minus x to x, so then we go back right. So then, using the right-hand rule, we're going top right, top left, bottom right, and that means the normal should be facing toward us. So this normal, as far as I can tell, is correct. This normal is the one that threw me off for a second. We're going 0 to 1. Goes from minus z to z. So it's going away from us first. Or sorry. Yeah, it's going away from us first. And then from here to 3, it's going away from us, and then it's going down. So away, down. And then from 3 to 2, way down, and then toward the screen. Away, down, toward the screen. If we follow that with the right-hand rule, the normal should be pointing to the left. Okay, so that's correct. Okay, I don't know what threw me off. It's also because it's stuck on more or less the negative x values. You expect it to be pointing to the left because it's the leftmost part of the cube. Okay, so for the lighting, this is the interesting part. So we have SL light applying the light to the arena. The light is in... I'm not certain that this is an actual position for the light, because this would put the light inside the cube, which doesn't make a whole lot of sense to me. However, what I assume it is that this is... I don't know how it's defined, but I assume this is a ray source of light. Light source's function only includes the direction vector. There we go. Direction of light rays does not include light intensity or color information. The direction of these light rays. Okay, so this is the ray picture of light. Monodirectional light angle. Yeah, that's what I figured. Light rays are defined as always coming from the direction specified by the direction vector. So, in this case, we start with the light pointing to the left, minus x. But now we are imposing a rotation. So first is a y rotation. So rotation about y will rotate the x pointing vector in and out of the screen by a variable amount, temp. So it's kind of like, almost like the light source was orbiting us, but also then there's a little bit of an x rotation to give it a vertical position away from the center. And then a Z rotation will give it, I mean, I'm not really sure if the Z rotation is even necessary here. It's just kind of giving it a little bit of an offset. Just kind of like wherever it was, it's just kind of rotated clockwise in terms of screen space, from what I can tell. Now, what does SL calc point do? They don't cover it here, so we got to go over here and figure it out. SL calc point. Oh, there we go. 3 entries. Multiply current matrix with the specified point and substitute. Oh, I didn't know that was a function. I could have used that several times. So this just applies the matrix that we build up with like 1 point. in this case, the light. But what is the in and what's the out? X, Y, Z, and answer. Answer is storage. So we take essentially a vector point in the Z direction, and we apply all these rotations to it, and store it in light. So this means nothing, because this is just an initialization. This is where we're actually doing work. So we take a vector pointed in the Z direction. That's where we start. We apply this variable temporary vector to it. I don't know why it's called temporary, because we're just iterating on it. We're not making it temporary. So in this case, let's start it with like 0, right? Because that's where it starts. Yeah. Starts with 0, and we give it an X rotation. So rotation around X, well, it's pointed away from us. Now we're tilting it, I'm guessing, upward by 15 degrees. So now it's pointed a little bit upward, so we're lighting it from slightly below and in front of it. And then we rotate around Z, and that will give us kind of like, in our perspective, rotation slightly to the left. So it's like we're initially lighting it from the bottom right in front of the cube from our perspective. And then as we apply this Y rotation, the Y rotation kind of makes it orbit, as far as I can tell, around the cube, which is what we see. Okay, well that's straightforward enough. Now let's see if we can do anything more interesting with the light. Does the light have a color? So this is like a theoretical treatment of lighting in general in terms of 3D space. And this is starting to approach what we actually do inside of Sgl. So light rays are always coming from the direction, blah, blah, blah. Polygon face attributes, color of the polygon, face, angle of incidence, and light shining on the colors are brighter. The closer the angle of incidence is to perpendicular, and darker the closer it is to the horizontal. The color is darkest when the angle of incidence is negative and perpendicular. So basically, if the light is coming from behind, it should be as dark as possible. Okay, so Pona, at the moment, that's going to be above my pay grade, but I will figure out more about the implications of what the difference between XP data and P data as I move my way through this tutorial series. But thank you. Now, right now, we are using P data, as far as I can tell. Yes. And I believe ZTP also uses P data, if I'm not mistaken, meaning that it would not be compatible with GoRad shading, if that's what you're saying is correct. Because if ZTP is using P data, I wouldn't be able to apply the GoRad as I'd like. I'd have to essentially go down the rabbit hole that every other 3D Saturn dev does and make their own new freaking format just to get an additional extra feature and end up breaking 10 million other features on the way. Am I understanding that correctly? Let's see. So it's just a vector, so it's just giving us a direction. So this is like white light. We can't shade with this light. And this is just matrix operations, I think. If you follow me at all, you'd already be familiar with that from my work in Blue Skies and Scenario. So what I'm talking about is, with ZTP, I am fairly certain that's not XP data, that's just P data. Maybe I'm... Okay. Well, it's fine. Like, I appreciate any help, even if you're only half listening. If I recall correctly, maybe ZTP is X. Okay, if it is, then it should be GoRad compatible. And it was just me misusing it that was making GoRad a nightmare. Again, because I was trying to reuse models, and reusing entity in RAM means anytime I apply shading, I believe every instance of that entity that I'm trying to draw would get the same shading, which is the issue. Okay, Could you elaborate, Ponut, on why that's an Sgl issue? In the meantime, let me go ahead and try to mess around with the program a little bit. Let's just make it, like, flat. Just rotations about the y-axis. In which case, it should just be orbiting around the cube, as far as I can tell. Or at least the apparent light would be. Again, this is all defined by rays. So it's still apparently orbiting around, but the problem is, now I'm seeing that is this an optical illusion, or is the top quad... Oh, the top quad is rotated, that's why. Let's unrotate the top quad. How about that? No X direction rotation, but yes, Y direction rotation. Oh, welcome back, Shane. We're working on lighting now. Yeah, so Goo-Rod? Can't I just call it Gonad? Okay, well, that's why they rotated it down by the X direction. Now you can't see the top or the bottom. But it does look like I'm orbiting the thing, which is nice. So, the Goo-Rod... I'm gonna have to learn how to Gorard. Okay, freaking... Okay, you know what? Let's do this. How to pronounce...
Gorod.
Gorod.
Gorod. Gorod. Gorod.
Okay. Gorod. Just call it Gorod. It not quite Goo-Rod, but Gorod is close enough. Okay. Well, okay. That mystery solved. No, it's fine. It's fine. We figured it out. Okay, anyway, whoa. Okay, did I break something, or was that old? No, okay, that was working. Let's clean that off. I don't really have much I want to do with directional flat white lighting, so let's move on. There we go. Okay, so we figured out how to light something, which is nice. So if you have nothing but unique P data, you can just brighten it up directionally. It's also kind of an issue because let's say I want to pretend that the light texture or the LED texture or whatever I have on the ceiling, it says, okay, that's a light source, right? So first off, I can't do point lighting. Which, I mean, that's probably too much of an ask for the Saturn, but I just can't without doing a lot of iterative calculations. The other thing, actually probably wouldn't be that bad, because if I put, like, the center coordinate of that face and recalculated lighting for every quad, I could do it, but Sgl put polygon works on collections of quads. So essentially, I'd have to decimate the room. But let's say I have the ceiling and the walls and the floor all separated out. I could then take the difference between the central coordinate of each of those things with my presumed light source and change the light direction per grouping as needed, and that would, in effect, create semi-directional lighting. So that would be useful, I would think. Coordinate transformation. Haven't we already been playing with this? You guys have been doing matrix transformations already. Again, this is not... I mean, if you've ever been on a Emerald Nova stream before, none of this should be new. There we go. Positive direction versus the Z-axis. Yeah, this is just using the right-hand rule. Z is into the screen. Curl your right hand around your right thumb while your thumb is pointing away from you. You see what direction positive is. Same for any other axis. Screen coordinates, standard 320 by 224. 0, 0 in the top left corner. Now, I'm used to, with Joe Engine, somehow it's shifting to the middle depending on the draw command, and I think that's just Joe trying to do me a favor. But no, it's just, you know, 160 and 112 for the center coordinate. Or at least the top left of the center coordinate. There's a 4-hour discussion with John Carmack. I might actually want to listen to that while playing Minecraft or something. Okay, so here's one of the early issues I experienced with Scenario, which is the projection plane. So there is a certain cutoff distance using frustum culling. And if an object... So here's your virtual position in space, this point right here. Here is the projection surface, and as far as I can tell, when an object comes closer than projection surface, you don't just get a really, really close view of the object, they just don't draw it. So that's something you need to keep in mind. Projection surface being the TV monitor, as Sgl puts it. I mean, there's a lot of impressive work in Doom and Quake, but unfortunately, not all of it can transfer over to the Saturn, because I think he does some floating point magic, if I remember correctly. Okay, so I guess that's probably a good way to explain it. Is essentially, you are a person holding a camera with a really long lens, and anything that is closer to you than the end of that lens is not going to get shown. Unless you're talking about like the focal plane array of the camera, of a digital camera or something. Oh, rendering only what you see. So Doom has a what's it called? Is it raycasting, I guess, where you draw closest to furthest away in strips. So like you sort out all the stuff in the room that's within your cone of vision, and the FOV in Doom is what, like, it's not 90 or something. It's either 70 or 90 or something like that. So everything within that cone of vision, and then you break it up into single pixel strips. And you draw, well, maybe it's not single pixel strips or something, but you draw that that vertical cross section of whatever that strip is, and now that you've drawn that, everything behind it is no longer going to be drawn. Single pixel strips. Okay, so I guess if you're used to, I haven't done Unity in a while, but if you're used to Unity, I guess that's the same picture. The near plane of the camera is between the near and the far plane is the only thing that you see. So anything closer than that, even if in a first-person game you would expect anything up to and including but barely including that point here to be drawn, just from a logical conclusion, it's not going to be. So you can get close enough to something where it disappears, unless you're careful. So the viewing volume is just the area that is what's being drawn. So perspective angle, I believe they're talking about their FOV here. And 60 is like I think, what's the word I'm trying to think of? Claustrophobic, yeah. 60 feels claustrophobic to me. I need, like, even on a 4.3, I need, like, 90. So they're telling us how to change our perspective angle. Oh, this is a fun demo. Actually, I kind of want to skip ahead to just go play with the demo. Do they have display level? SLZ display. Okay, there we go. Position, dividing point between the viewpoints. So 1/2, 1/4, 1/8. We have a uint 16, but what's the actual maximum display level we can go to? 1/8. So SLZ display level 3 is the maximum that we can do for 1/8. And I'm guessing 0 just puts it at projection surface. So we can expand the area in which something close to us can be drawn by setting this value correctly. And I'm guessing 3 is as close as we can get. So anything within 1/8 of the projection surface and your viewpoint is not being drawn. But that's as much as you're going to get, is that 7/8 extra room. Is this 3-2 or 4-2? Where am I at? Yeah, 4-2. Okay, there we go. And I think 4-2 I also already have set up. So let's play. Up. Yeah, just play with it. Wow, they already... Defined but not used. Interesting. So we have a cube that is just kind of offset on the screen, and it looks like it's rotated at some angle to let us view the top and the sides. But we're playing with the FOV in such a dramatic way that we're able to see way too much. It's almost like a relativistic simulation. We can actually see faces of the cube we probably shouldn't be able to see because we can see behind it when we get really, really high FOV. I'm not even sure how that works, because I feel like that you shouldn't be able to see behind the cube like that. But you can see the red face popping in and out with the changing perspective. But do we have SL set Z display? I don't see it in here. And it should happen before the while loop. Here, let's do this. SL Z display. Okay, let me make sure I'm actually typing it right. SL Z DSP level. Capital L. DSP level. And I believe 3 is the closest we get. So this is just something I would just default have on, is just 3. And I think you pretty much have to put it after the initialization or it wouldn't make a lot of sense. 4.Z2. What's Z about it? Did I type that? Did I do that? Okay, we got the angle, we got position. So it's offset. So we're going up to 160 and down to 20. Now, is that the actual limits of the function itself? Okay. An overflow error will occur. Well, let's not play with that then. Determines... Apparently it's just 0, 1, 2, and 3. So that's not much to play with here. So it's just it's a fun demo, but there's not much to play with. There we go, another typo. Like, it wouldn't be an Sgl sample without a typo. Then we have transformations, so we have translations, mirroring, SL translate 1, no, that's wrong. SL scale. Okay, so we have so the scaling changes the size of something, but a negative scale inverts it. So in this case, if you want to just mirror image something around an axis, this is incorrect. This is mirroring around the y-axis, but the code here is mirroring around the x. This should be 1 minus 1, 1. Okay. This is correct. Why am I getting freaking spam emails? Okay, there we go. Enlargement, SL scale. This one is correct as well. So times 3 along the x, it gets bigger along x. Mirroring about y. Or wait, no, sorry. I was mistaken. So it's not a rotation about an axis. It's a rotation. It's a deformation along a direction. So this is indeed correct, because it's deforming it minus x direction. So that's where the mirror is happening. I'm sorry. I was thinking in terms of rotations. And rotations, in order to get the same effect, you'd want to rotate about y. Okay. Object rotation, there's your standard rotation matrix setup. Again, 0, 0, 0 on the bottom because I don't know what the bottom does yet. This is sample 431. Let's just go open up sample 431. Looks like we only have a plane. So we're rotating the plane, and it's in dual plane mode because I'm pretty sure we're viewing the back and the front. There we go. So what's going on here? SL rotate by angle around X, around Y, around Z. Angle of X is 0, angle of Y is 0, angle of Z is 0, and all of a sudden we are changing the angle of Y by 5 degrees per frame. Dual plane. Single normal, normal. Again, the Y direction. Am I going crazy? The normal should be my Z, right? Okay, 0, 1, 2, 3. Okay, top left, top right, bottom left. So the normal, if we're following the right-hand rule, should be going away from us. It should be 1, right? I mean, it's not going to make a difference here until we go into single plane mode. But just to prove to myself that this is what's happening, let's turn this into single plane. Single with an E. There we go. And so when it rotates away from us, because we're in single plane mode, it's getting backface called, so we're only seeing it half the time. That's what I expect to happen. Now, let's say we go back and use the Y normal that we started with. That's probably going to be incorrect, and because the Y normal is never rotating out of our frame of reference, it's not going to get backface culled, even though we are in single plane mode. Yep. So that normal is indeed incorrect. Sega made a mistake, and I'm sure they got a talking to from their boss at some point between 1994 and today. What else are we doing here? We're just doing, rotations are boring because we've done them to death. Let's move on to 2-axis rotation routine for cube. This is like the same demo, but different. Unfortunately, I cannot tolerate lyrics on the stream, so I gotta go find this Sonic Adventure 2 track and remove it from the stream. I already miss it, but rules are rules. Okay, so now we got a cube rotating along 2 axes. It's entertaining enough for me to leave you guys for 2 seconds to go take a bio break. I will be right back. And back. And as I said before, rotations are kind of boring. This is just 2 rotations happening at once. It makes an interesting effect visually, but not interesting intellectually. We are just iterating X and Y rotations every frame. Otherwise, nothing more useful is happening, so let us move on. Shifting object. This is just translation. Oh, there's another boring demo. Alright, let's open it up. I'm not even going to open up the polygon because we know it's just a flat polygon. It's just going to be something that's going to be bouncing back and forth on the screen. Yep. And it's using sinusoidal movement to moderate how fast it's going by the time it hits the edge and also automatically revert it. So, yeah, okay, cool. Should see it right over... There we go. Multiply position X. So this is 220 units away from us in... And now we take the sine of whatever this angle is here, increasing by 5 degrees per frame, multiply it through by z and store it in our x position, which is why it's going left and right and left and right. And if we were actually changing the z position along with that, we would be simulating circular movement, but we're not, because it's going along a flat plane of motion. So it's like a projection of circular movement, if anything, without the perspective correction of changing the size of the plane that we're looking at. That's about all that's going on here. Okay, SL scale, we've seen this before. Make it bigger, make it smaller, make it flip. Disappears along 0. Okay, that's straightforward, but let's go ahead and go to 434. Oh, let me clean up after myself. We always got to clean up after yourselves or your Google Drive starts to blow up. In fact, let me pause syncing for a second because I'm probably uploading and deleting too much crap. Jeez, I'm getting really lazy here. It's the last time I... Okay. Alright. Main. So let's just try to see what we're doing here. Flag. Okay, so we're stretching and squeezing and mirroring whatchamacallit, polygon. This would be a lot more interesting with the texture. But there it is. And this is another fun effect you can try using. This might be like a substitution for an animation for a very simple mesh, if you were so inclined. Kind of like a cartoonish, I just got hit with a hammer and now I'm like wobbling because of it. Let's clean up. Go to section 5 of chapter 4, which is... Oh, okay, so sequence of rotation. This is something important to know. So if you do a rotation followed by a shift, that's different than doing a shift followed by a rotation. Now, I'm not sure if this is the correct way of demonstrating this, but... I mean, this is something I always end up getting wrong the first time and having to play with to get it correct and then just not touching it again. But, essentially, the trick you more or less figure out is that one sequence is an effective third-person camera and the other sequence is an effective first-person camera. So generally, when you're looking at something, you first shift it and then you rotate it. Unless, no, wait, or maybe you rotate it and then you shift. See, this is what I'm talking about. I always get it wrong the first time. I'm just not going to say anything about that. Disregard. 2D clipping. We'll use 2D graphic examples to induce. The bottom right is wrong. That's what I thought it would be, because even if you shift it first, you're rotating. You should be rotating around the origin, so it should be like down here. It should look closer to this. And then if this one rotates first and then shifts by 4 to the right, I would assume it would look like this, just over here and not down here. So these two looked wrong to me, but I didn't want to correct them because I always get it wrong whenever I think about it first time. So yeah, these two are transposed. Again, Sgl manual is always wrong sometimes. Okay, clipping boundary. So this is just telling you you're not going to see stuff that's not going to be on screen, which almost feels tautological, but there's also there's additional considerations to have here, and it's not just the fact that they're clipping off part of it. It's that often you'll get warping when there's something significantly off screen. Now we're not going to see that without a texture present, because if it's just flat shaded, it's flat. In a certain scenario, due to computing speed and drawing speed, whether the object is displayed or not is determined by the percentage of the object that is in clipping area. So you can't get things that just flat out drop out of drawing distance if they're off screen enough. Now, the problem you generally see in games is not that they're... Well, you sometimes see this, like in Sega Rally. If you look at the bottom of the screen, when you're, especially when you're in like first-person mode, parts of the track just kind of disappear because that specific quad is too far off screen, but it's still enough of it is there to be noticeable. Oh, okay, so the vertex is getting too close, not too far off screen. And then you have problems like Daytona, which I believe they're just running out of work area and they're not doing anything to fix it. In terms of like entire audiences in the stands disappearing when you get too far away from them. So we already know about the frustum culling. We've gone over that with... but what else is there? So we have the projection surface, we have the display level, so this looks like display level 1, giving us 1/2 of the distance. There's your clipping boundary. So I mean, this feels like a useless distinction to me, of just saying whatever's off screen you're not going to see. Like, of course, yeah, duh. And the only thing I would worry about is if it's too far off screen, you start warping. Oh, the window. This is the fun thing. So you can get two different, essentially rendering pictures on the same screen by using a window. Now, so essentially the window's saying this portion of the screen. I don't get how the rear surface boundary works, especially the way that it's left, right, bottom, top. Z limit. What's the Z limit do? That's probably what I'm looking for. So this tells you like what part of the screen is getting windowed out. So you're like doing a different rendering zone or whatever. So the window starts at the projection surface or at... Okay, so we have to get the terminology right. There's a projection surface, and there's that... whatchamacallit? Projection surface, and then what's the area closer? Display level. So does the window start at... It looks like the window starts at the display level, but it's defined by the projection surface, which makes perfect sense. Because if it wasn't starting at the display level, then you'd be able to see things in front of the window would be worthless. But it's defined at the projection surface in terms of the coordinates that you're setting, and then it's going down or away from the projection surface by Z limit. Determine how deep of a space from the forward boundary is specified in the function Z. Oh, wait. Am I getting this wrong? So in this case, the near plane is the display level, as that's what they were labeling it as. But again, let's go ahead and call it the near plane. So the Z limit, I thought, was how far away you are from the projection surface. But now they're saying how deep of a space from the forward boundary surface specified in Z display level will be actually projected. onto the projection surface. Z limit -1 is specified. Z limit value for the window that was last set is used. No other windows. Value for default window. I don't even know what this is supposed to mean. Besides max 16-bit. I guess that's something we're going to have to play with to figure out what it means. The same size as the monitor. The rear boundary coordinate is essentially 16-bit int max. Or not, no, that's signed int max. Why is it signed? Oh, I guess because you can have negative. Okay, fine, whatever. And the vanishing point is set at the center of the screen. So the vanishing point, that's another important distinction. This is essentially a perspective technique. So if you have, well, I mean, the cube does a better job of explaining it than I do. If you have a bunch of parallel lines in the actual physical space, but your perspective is going to distort those lines, the vanishing point is where those lines meet. In this case, if you put the vanishing point somewhere far away from the center of the screen, things are going to distort as if they're being projected toward that location. In this case, looking like essentially, it's like you're looking at it from an angle if you play with the angle of the vanishing point. I feel like we're not going to learn as much as we can if we just don't start playing with the actual samples. Let's go to S45. Oh wow, I already compiled this at some point. So we have our Z limit of 150. Let's just run it. So they're doing a little bit of tomfoolery here. There is a window that's moving around into... Essentially, we're looking at two different spaces at once. One of them, I believe, is just a cube that we're looking at from a certain perspective, such that maybe it's not a cube, maybe it's just like the interior of a cube. So we're looking at a small square, apparently inside of a large square, but I believe this is actually a cube. But we can go into the P data and find out. And inside, we see a rotating cube. The problem is the window keeps moving around to demonstrate the power of being able to define a window. So you can't always see what the cube is doing. But I can see this being useful for some visual effect where, like, maybe you're trying to simulate a heads-up display and view two different kinds of things at once, or maybe you want to set up a rear view camera or something like that. So like in a racing game, if you wanted to set up a rear view mirror, you can literally just have the window defined as a small portion of the screen that's rendering just the track, but with the reversed camera angle. It could be interesting. Let's play with this to see what we're actually looking at and make sense of it. So here's a point plane, here's a point cube, and then there is plane. Oh, it literally is two squares. Two squares overlapping, one bigger than the other. So I thought it was the interior of a cube. It's not, it's just two squares. The cube is the cube. Okay, finally they're going into single plane mode. Well, here's the thing. If you set up a rear view camera and then put a frame around it, so you'd have a rectangular rear view mirror, but with a frame around it that made it look like more soft corner like you would in an actual car. And then you just set up a rendering pipeline where you invert the Z direction of your camera. It should do what I'm describing. So like you punch a hole in the screen, yes, where you are rendering a different thing, but the thing that you're rendering is just the same thing you're rendering but backwards, or from a 180 degree rotated camera angle. And that should, if you set the Z scale to -1, act as an effective rear view camera. Okay, yeah, but have we... I mean, I've asked this question before in Saturn Dev, but isn't there an issue with rendering to texture with... I mean, it's probably going to be the same issue with the window, but isn't the issue that it's hard to render to texture when you're talking about combining VDP2 and 1 effects? Like, do we have the ability to render to texture taking stuff from VDP2? Because as far as I can tell, last time I asked about it, it was still uncertain how we render things to texture to get everything that's actually visible in a scene, including VDP2, onto that texture. So like the Rayman effect, where at the end of a Rayman stage, they freeze the screen and they take that and they project it onto different three-dimensional meshes. So they are rendering to texture somehow, but it's not clear how it's being done, and apparently there's an issue accessing VDP2 frame buffer directly to copy things over and draw things. But yeah, rendering to texture would be one way of doing it, but I believe you could use this window to do that same effect. And I think it would be an interesting way of doing it. So, let us take away the translation of the window. So where is the actual window command? There's put polygon, SL window, top left, bottom right. Ah, there we go. So let's comment this out to keep this thing steady. Ah, dang it. It's too far up. Let's see. Left, top, bottom, right. Where are you at? Okay, so top is 30, bottom is 80. The screen is 224, so we want 112. 30 to 80 is 50, so 25, right? So minus 25, and then 112 plus 25. And then right, let's go ahead and just completely center it on screen. 320, one half of that is 160 plus 25, and then we're going to have 160 minus 25. So we get a proper square, unless we're doing 4-3, but whatever. I'm doing a square. Squares are fun. No lyrics on stream. You know the rules. Whoever you are. What is this? Oh, is this my hero from Sonic 3D Blast? I don't know who sings this, but she's off. There we go. I am not a fan of this one either. What is with all the crap? You'd think after 3 years I would have like trimmed all the stuff I don't like off of my playlist. Okay, wait, no, it's growing on me. I'll let it sit for a little bit, see if I like it better after I'm done. Okay, so I got the window to freaking calm down so we actually look at something. Oh, you know what? I have a better idea. V-move. Let's reprogram this slightly. Let's do, V-move. There we go. So now let's do offset. V off. H off. So left and right are modified by V offset. Oh, I did that before. Okay. Plus V offset. Plus V offset. There we go. Okay, and then H offset. Plus that. Plus that. Okay, so V move, or... Let's see. H off. V off is equal to H move, but not equal to, but plus equals. Cool. All right. I already moved that over here, so let's get rid of that. That doesn't change. Cube. Let's have a little bit of fun. After we're done with that, let's translate. Oops. After we've done our rotations, let's translate by the offset. So we got our V off. H off. And of course, 0. Let's see if this does what I think it does. Dang it. The cube is not moving because the translation needs to be in fixed. And it may or may not need to be sign reversed. So if we see it moving in the opposite direction, I gotta sign reverse it. Heyo! Oh! What is going on? Did I do this in the wrong order? It's kind of doing what I want, but not really. Position 2, 0, 0, and... Oh, that is disappointing. Because that makes it hard, you know? Because I thought I was doing something clever here, but yeah, you're right. The two different spaces with the perspective is going to make it difficult. Unless I bring the cube much, much closer. But maybe we can try doing that. But then it's going to look too big. Ah. Okay, you know what? I tried. It's not worth beating my head against this thing for just a novelty gimmick. But I think you guys saw what I was trying to do. I was trying to get the cube to move in its own space to track at the same speed where the window was moving in its space. It would have been fun, like a little window screensaver thing, but it's going to require too much math for me to backtrack the 3D perspective that I need. So, we're moving on. Yeah. So like the cube is going to be a certain distance away, and I'll just track the center of the cube. Where the initial coordinate transformation was, and then essentially do some linear algebra to get it to where it needs to be in terms of projection plane, as opposed to where it is, which is far away from projection plane. So yeah, I know how to do that, I just don't want to right now. Extent of effects of window. Twice with this. Okay, so basically you can only have two windows, and the first window is like the one where the game actually exists. Now, this might be useful. I pulled up this example in Sega Extreme as well. If I just, you know, Ultima Underworld, right? If you were doing some really stressful stuff and you wanted to, dang it. I mean, there we go. So let's say you're doing some really stressful stuff on your system, and you wanted to limit how many quads you actually need to draw. You have this little window here where you're actually drawing the quads. But then all around it, you have some VDP2 stuff. And if Ponut's explanation is what I understood correctly, this resolution here that VDP1 is displaying at can be a lower resolution than the rest of this stuff. So you can have some really fine detailed HUD with icons and text and stuff. And then have this look like kind of a more rough 3D environment. And that would be a valid way of constructing a game in the tradition of early 90s, late 80s, three-dimensional... Well, not late 80s, I think it's just early 90s. Early mid-90s, three-dimensional PC games. Ultima Underworld, Daggerfall, and the like. What year did this come out? 92, yeah, early 90s. But I don't know if there's anything late 80s that also does something similar. Well, let me check real quick. Krondor. Betrayal of Krondor, 97. Why does it look the way it does for 1997? No, not Return. Betrayal. Betrayal at Krondor. No, I don't believe Betrayal at Krondor came out in 1997. It looks like this. That's like 92 graphics at best. There we go, 93. Yeah, that's what I figured. Okay. Anyway, stuff like that's possible. There we go. Say thanks, opponent. So you can have a 320 by 480 screen. Sword and Serpents on NES was... What's Sword and Serpents? But it's not like the NES was actually trying to put polygons on screen. I don't want to play someone else's YouTube video because that's instantly going to get claimed when I try to do it. So this feels like the same trick that Yoshinaka used in Final Fantasy. Or, sorry, not Final... Phantasy Star. I'm going to get murdered on... I'm going to get canceled on social media for making that mistake. But yeah, you see, they're just doing perspective, but I'm pretty sure that perspective is pre-baked into the game, the same way it was in Phantasy Star, where like they've got all the sprites set up correctly, and they're just looking up at a table of, okay, what do we do when there's a wall here, etc., etc. And also, yeah, on the NES, it looks good for the NES, but it does not look good in a general sense. That's actually relatively impressive. I don't think I'd be able to make that kind of art. I mean, that guy looks hideous, but that's the goal. Yeah. And it's one of the reasons why you'd want to use this window effect. Otherwise, for the most part, I think most people making games are not going to be interested in using windows as such. But this is also an exercise to understand coordinate transformations explained in a way that is technically incorrect as of... not here. Here! So they set you up for failure already, and then you keep going. But, you know, play with it to figure out... Lyrics on stream again? This isn't even in an episode 3 song. Why is this in episode 3? Whatever. Oh, I love the song. Okay. Yeah. So now we've done some coordinate transformations. We played with windows. Windows are more of a novelty. Coordinate transformations are fundamental and vital, and you should understand them very well. Yeah. So, like, I remember when I was doing, in year 1, when I was playing around with Scenario, was it year 1 or year 2? Might have been year 1. But I was saying, yeah, like, the whole environment is quads. I didn't even have a proper VDP2 background until, like, the final submission time during year 2. But, like, I was just putting 1,500 quads on screen. And they were in the pipeline. They weren't not all of them were on screen. They were like 50% were backface called or something like that. But like I didn't get slowdown from having all those quads on screen. So like people were telling me that, you know, there's no way you can get like 60 frames with 80 quads, but I was having like 60 frames and some fundamental game logic with basically filling up the buffer for drawing. So even if you backface call like 50% of what I'm looking at, that's still like filling up. What's the default size? Like 1700 quads? No, I was getting 60. Are you sure it was 30? I remember getting 60. Because when I was looking in the model viewer, I had a frame count up on the top. I was seeing 62.5 in Mednafen, which means 60, but Mednafen runs fast. Oh, okay. Mednafen was lying to me, maybe. Okay, I buy that. Okay, fine, whatever, I got 30. But I wasn't far away enough from 60 that if I didn't make, you know, a cut here or there, I would not have been able to get 60. Demo_A, bouncing cube. We are, okay, so this is like a midterm kind of program. We have drawing, we have a light source, we have coordinate systems, modeling transformations, drawing regions with windows, and clipping. I mean, the clipping is just stuff's off screen, you're not going to see it, but whatever. I still don't understand why clipping is like a fundamental thing they need to go over. It just feels too obvious. Like, why are they covering it as if it's like a design tool or something? Whatever, let's open up Demo A and try to get it to run. So Demo_A. Oh yeah, this one's already set up. I didn't think I got this far. That was fun. Oh, maybe I skipped ahead and did this when I was digging through the samples before the show. I don't see where windows are coming into play here. This is just a fun little cube is bouncing around inside of another cube kind of deal. And I'm not certain if the big cube is clipping off the near plane because it's inside of the near plane, or if it's a five-sided cube. So let's take a look inside the polygon. So we have plane 1. There's 1, 2, 3, 4. Oh, there's a point. Let's do there you go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So these are two different identically sized cubes. Did they set up a normal for one of the cubes differently? So we're going to want to see if there's... Nope. There's one forward, one back, one forward, one back. Oh, no, it's inverted. Is it? Yeah, it's inverted. So the normals for the other one is inverted, so it's just being backface called. That's why we can see inside of it. So let's say you didn't have clipping. What exactly would that have meant? Would that have been like an overflow error? Would you have just drawn the rest of the texture on the other side of the screen? Like, what exactly is being said when they are clipping? Or rather, what is the alternative to clipping? Ah, okay. So it would have been a more catastrophic thing. So basically, it's handling something automatically that otherwise you'd have to handle yourself. Because overwriting RAM would be catastrophic. Okay. I get it. Okay, so I guess they're just bragging, say, hey, we're doing this for you. This is automatic. I guess back in 94 was, or 95, or whenever this came out. I think 95 is when we finally got Sgl, right? So 94, everyone was still, like, left to their own devices on their own. Sega throwing third-party devs to the wolves. Now, let's see the projection surface. Reflect extent. Where is that? Okay, well, it's a feature, but like the Sgl manual is what's explaining that feature, unless they had other documentation earlier that also explained it, and it's just going over the same stuff again. But it just feels like if you have it, it's so obvious you don't need to talk about it, but if you don't have it, it is something you need to consider. So yeah, I guess from the perspective of someone in 1995, this is something worth going over. I guess we're doing lighting, matrix rotation. Okay, reflect extent. So we're saying once the cube hits, I guess, 85 units in some direction, you flip it around. X speed, Y speed, Z speed. Okay, but what is the size of the big cube that we're seeing the internals of? There should be an SL scale for that because they're both set to size 1 without it, right? Is there not a scale? No. There's a scale. There's a scale. There's no scale. So what are we looking at? I don't get it. So this is the cube that's moving around. This should be the little cube. This would be the cube of size 1, if one is to be believed. Oh, wait. Okay, no, sorry. I got this wrong. So I have normals of unit 1, as they all should be, but now we have the actual planes of the cubes. So one of these cubes is 30 on a side, and the other cube is 200 on a side. And apparently, let me see, 30... Square root 2 times 15. What's that? Let's do that real quick. So 2 square root times 15, 21 minus 100, 78. So they didn't quite get the worst case scenario, but I guess they got it close enough where you don't have to worry about it. Because they're changing direction every time it hits 85, and technically speaking, if it was rotated the exact wrong way, it would have to be within 78 before it started clipping, but whatever. Did they push it 175 units away? Because it looks like it's centered, but maybe they... Oh yeah, right. So then the reflection against those surfaces is more of a perspective trick than anything, because it's not actually... The other cube isn't actually there. Oh, no, 270 away. What? So that wouldn't that put it close to the back? Because they're both centered at 0 right now, right? This guy's being pushed 170 away. This guy's being pushed 270 away. This guy has half length of 100. So presumably this guy would be somewhere way back, but Position 1, position 2. So we got position 1, Position 2. Where's position 2? So position 2 by default is 100. Position 1... Oh, they started the same default position. Okay. Okay. So I just had to... Right. Yeah, I feel like there should be a comment somewhere. That's the one thing about this. You never see any comments anywhere in these files. Well. Okay. So it is moving in realistic space. It's just the reflection points are not quite what they should be for worst case scenario. And they're obviously not implementing any sort of plane-plane collision checks to see when they actually do touch, or when the point of a cube touches the plane. Which is probably what I would have tried to do. But they're getting a good enough effect, I guess. I mean, heck, an axis-oriented bounding box would have done the job, too. I don't know that there's anything for us to play with here. This is just a bouncing box. Moving on, Chapter 5! Matrices, again, because we weren't already doing those, I guess. This is the basic concept of a 2x2 matrix operation, but the Saturn uses 3x4s, and it treats them as 3x3s for the purposes of multiplication, so why are they showing it like this? So, the thing is, they don't even put down SLZ display, which would give them more room to work with. So here's init, print, and then they just start defining stuff and go, and they could be giving themselves SLZ display level 3 to at least give them a little bit more wiggle room in that regard. In fact, while we're here, SLZ display level 3, let's see if I... Well, that shouldn't actually affect anything because we're backface culling. So yeah, we're not going to see anything different, but whatever. Is it defaulting to 1 or 0? Is 0 a valid entry for Z display level? I thought it was. I thought it was implied that 0 meant that you were actually clipping at the projection plane. Well, let's see if it throws an error if I try doing that. So this is probably not the best demo to try and doing that with because I don't see any difference, but yeah, whatever. It doesn't throw an error. Okay. Let's assume it's just supposed to be a 3 because of reasons. Clean up after ourselves. And move on to 5.2. So they're telling us how matrix multiplication works in a way that doesn't apply to how we're doing it in the Saturn, because we do it with 3x3s. Here's a stack picture, which is helpful in terms of figuring out what you're doing here. So you push to put a matrix on the stack that you can manipulate, and you dick around with it, and then when you're done using it, you pop it off, and then you're stuck with what's on the bottom. I don't know if there's ever a situation in which we want to directly manipulate this one, because generally I always push a matrix before I start using it, so this bottom one, the initial one down here, doesn't seem to ever do anything. Sgl init matrix. This is how you instantiate a matrix, I think. Initialize the stack and matrix variables after initialization. The environment matrix is stored in the stack as the current matrix. Hey, Shadow Mask. Thanks for bringing people in. Did you do your movie night? I've been programming for a little bit. Okay, maybe I actually need to read this section because I don't think I'm explaining it right. Structure model for efficient concept functions. Matrix at the bottom of the stack is called the current matrix. The bottom of the stack is the current. The various matrix transformations are performed on the current matrix. Okay, so no, this is the new one. This is the one that we don't bother messing around with, is it? But it's saying that this is M2. So is this the bottom or the top? Oh, okay. The terminology and the picture make it a little bit confusing. Okay, so the first way I said it was correct. We have our M1, we push, so we get a new matrix on top. It's just a copy of M1, I guess. We play around with it, it changes, and then we pop it off. Now we're stuck with M1 again, which presumably is the untouched identity matrix that we'll never actually bother altering. Copies the current matrix to the bottom of the stack. Okay, so the reason why we don't want to touch this the bottom one down here is because that is our reference point. So we want to keep this as identity. Shifts the current matrix to the designation to the bottom level. And so we have let's actually for a second. Oh. Let's get this thing ready for us to actually use it. Main.c, polygon.c, open up main, polygon, doing int main void, get rid of sub, polygon is fine, and then let's copy over the makefile, cd, zte, and my batch, and common.h. What do you mean plates on Japan? I have no idea what you're talking about, Knight. Okay. Now, there should be a matrix stack size argument somewhere around in here. Max vertices, max event. Maybe it's not in work area. Maybe it's in common. But somewhere in here, we describe... Yeah. So that's what threw me off with the language, because I explained it correctly the first time, and then I looked at it and said, oh, the bottom? Well, I guess this is the bottom. No, it's the top. For reasons. I don't know. That's just how they drew it. I mean, it makes more sense this way. But first off... No, this isn't even the same discussion. This is hierarchical structures. This is something completely different. But why are they plotting it on an XY graph? That has nothing to do with what's going on here. SL perspective. Okay, so that's like your default. So, but generally speaking, you want to keep that identity. Like, you can play with SL perspective to make it like default by rotating to the right or something. Maybe I missed it. Maybe I skimmed over it. Let's search SL perspective. There's SL look at, but this is in chapter 6 too. So we don't talk about SL perspective for another chapter. Just kind of funny. No lyrics on stream. Okay, so back to the matrix stack. What I was looking for specifically was we have... Okay. Am I going crazy? Because I remember seeing this. I remember seeing an argument that basically said, here's how many matrices you can put in your stack. Here's the size of your matrix stack. Event buffer, work buffer, main... SL look at is what's it. Okay, let's see if we can find SL look at. SL look at 7 entries. Camera definition and setup in Chapter 6. Again, they don't talk about it until Chapter 6. We're in Chapter 5 still. So they don't start with it, but I guess we'll get to it. I'm trying to look for the argument. Maybe I just need to search for it. Mat. Is it case sensitive? No. I thought there was a way to customize your matrix stack size in your work area. For some reason, I remember seeing that. There's a master stack and slave stack, but that's for, like, commands, I think. Vertices, polygons, events, work. Sprite, P buffer. Command buffer. So honestly, I don't know what any of these things do. PCM work. Pono, do you even use that with Pony Sound? PCM work size? I'm sure you do in some form. Anyway, I'm gonna stop messing around with the stuff I don't really understand. Max events, max works, work area, translates PCM, PCM size, master stack. Dynamic memory size. To load data. Oh, actually, that's right. Knight, while you're here, taking a quick look at this memory map, you said you wanted a certain area reserved for the online, the Netlink OS. Could you remind me what that was? Okay. So, Pono, I don't know if there's a way for me to... here, let me open the work area back up. If there's a way for me to zero out the bits that you don't use. So, if PCM work size... Well, I mean, it frees up memory. So, if PCM work size... Or PCM size, where's that? It's probably under common. I'm using this, and I can just set it to 0, and I save myself... well, I guess I don't save myself much of anything at all. Never mind. Hey, kilobyte's a kilobyte. Okay, but let's look at the memory map real quick, now that we're here and I'm distracted. 600 2F00. As far as I can tell, stuff just starts after that. Here's a slave stack. System work starts here. So wait, system work starts after the... So master stack starts after the slave stack. That's weird to me, but okay. Just real quick, let's see if we can't find the memory map. No, not that one. There we go. So, starting at here, 600 to 000. Okay. Master stack is at the end of RAM. This is system work. But it says the master stack is here. Between 600 1000 and 600 2000. UI though. Okay. System work. Oh, okay. So it's changed. For reasons. So by default, the area that you want free is from here through to user, program, and data. So how do we set that? I believe that is the work area, is it not? Honestly, I don't think I'd be able to tell whether or not I'm actually in compliance with what you need without actually just compiling and running and checking the memory map. So let's just do that. Oh, we got some Ristar going on. That's nice. Okay, so if I shift the work area and change the size, well, that's neat. Then presumably that would accomplish what Knight needs, which is freeing up the portion of RAM that is needed to be free. So let's let's see, what am I looking for? Alt 3 for memory. Oh, this is gonna take forever. How do I navigate to a specific memory address? Select line number. Okay. Enter. Go to address 6004800. Or do I need to... Oh, X. That is not a... Arrow key just moves me around like this. LT and GT? No, wait, this is the bus. I need to look at high work RAM, right? So high work RAM, I only have addresses up to... here. So the high work RAM goes up to 1, 2, 3, 4, 5 digits. Okay. So in reality, yeah, they mask out the 6.0. So you want me to free up 2F00. So 2F00 here, and free that out to 5800. So clearly, stuff is happening. Multiple things are happening. There's 2 banks of information. Okay, so one of those banks of information is IP bin, which I assume your program would have like overwritten somehow, or I mean, it would be free to do that, I guess. But what I'm concerned with is the 2F00, the first bit. There's stuff here for a solid while. And I'm guessing that's a stack of some kind that needs to move. Would that be under the make file? I don't know where that the region free stuff is being injected. I figured it'd be somewhere around here. Inside the makefile, because it's not like there's a code that does that inside of Sgl. Okay, that's just how you build the disk. There's IP bin. So, do I need to make a customized IP bin then with that stuff removed? And on top of that, what's in sgl.linker is under command directory. Command directory is compiler directory / common. So let's go take a look. I don't see anything special in here. SLS start or SL start. Yeah, but this is defining. I believe this would be like the default if we go back to the memory rack. This is basically the work area, user and program data. This should be where we're working out of. Now, I am very cautiously okay. So, is this not something that would be taken care of inside of common.h with... Oh, no, that's completely different. SLDef. So this common.h is me customizing the work area. But where does it actually say 4,000? I'm not seeing an address with 4,000 here. I don't see a 600 4,000 address in common. And if I go into work area, there's no addresses determined at all. Okay. So then... Sega does not want you playing with that. Oh! Settrack, thanks for the follow. So, this may be a little bit high level, but right now we're changing like the memory arrangement of Sgl to be compatible with Night of Dragons Netlink code so that I am able to just integrate whatever Netlink operating system that he comes up with for any potential online capability for whatever game I'd be making. So, it's not in common.h. Do I have to go up to SLDef? So, wait. Knight, this is something... Okay. Knight, this is something that SSP can fix. You can patch out my IP bin and insert your Netlink OS at the same time. And I don't think I would change anything about my code aside from that where that work area is put. No? Okay, so then how do I... That's not... I gotta find out a place where, like, some basic fundamental memory addresses are being defined. So we have the makefile telling us that the Sgl linker script is here, and this Sgl linker script is telling us SLS start is starting at 604,000. If I just change this by itself, yeah, that is where my program starts. That is where I start inserting the actual code of the program. So let's save the linker script. Sgl.linker dot original. There we go. And let us now alter this to, what was it, 5800? And see if I can still compile and run. Okay, so if it's just a matter of changing this linker script without touching any of this other stuff, even though this other stuff is also doing hard definitions of where stuff is in RAM, will that make a difference? Let's find out. It compiles somehow. It's stuck. So clearly that was not sufficient to get things to run correctly. Yeah, it's not working. There's something was missed. It has to be something in common.h, right? Like something is being written in a place where it shouldn't be written. System variables. Let's see. I get 400 bytes to play with at the end of RAM. Is that what this is telling me? Looks about right. Stack area, command buffer, p buffer, sprite buffer, blah 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 blah. We need to move user program and data. Now, where is the definition for user area? Sgl work area 60C. You know what? Let me zip this up. Because the one on my site is not up to date. I'm waiting on Fafling to finish doing the edits that he wants to do. 205 megabytes? Are you freaking serious? That can't be real. Now, you're on Windows, right? So I can like strip a lot of stuff out of here. So here's what I'm gonna do. First off, all this stuff, only thing you really need to keep is test and maybe work area. And right now we're playing with, what are we playing with? 5-2, let's just keep things consistent. I'll just keep 5-2. And everything else can go. Oh, there's like most of the size. And I'm also going to drop the Mac and Linux stuff so that I can transfer to you as quickly as possible. There. So here's work area, which is its own thing. And maybe I should be playing with that as well. And then there's test and S-2 for the projects that we're working on. Compiler. No Linux. No Mac. Common and Windows stay. Emulators. Do that. About as small as I can reasonably make it. Out of curiosity, let's look at SMP work. This looks exactly the same as work area.c, or sorry, common.h. Just slightly formatted differently. Let's see, work area.c. Okay, this is just a generic copy, but okay, fine. Here. You can have this 15 meg file. You cannot have this 15 meg file because it is too big. I can try to break it up into chunks. Rename into just small. Now let's see if we can do add to archive. And how do we do this? Okay, volume. Let's do 5 meg volumes. 7-zip. I hope it knows what 5 megs means. Oh, so it does. This is so dumb. We need, like, a direct file transfer protocol that isn't like, hey, you need to set up your own freaking web server to do this. There you go. I hope you have 7-zip. Anyway, back to what we were doing. No, I wasn't in here. I was in here. Okay, so while Knight tries to brainstorm what that is, I gotta go back and fix my Sgl linker script to make it work again. So that was common, Sgl linker. There we go. And we'll stop playing with things that are not meant to be played with, and we'll try to run the script again. Need some water. Okay, we got 2 blocks apparently orbiting each other while moving around in space. Oh, that was fast. What's the problem? Okay, well, it's directly loading an IP bin, so I don't think it's trying to modify the IP bin. So if you want like a customized IP bin, you gotta send me one. Okay, so then, is this something I can fix from here, or do you need to send me a fixed IP bin? Because I don't know how to change where the IP bin is loaded. Cool. Where and how? Let's go back in the linker. Okay. So we want to send this thing over to 58. And I'm guessing Joe Engine makefile? Okay, this IP bin. Oh, do I actually, like, straight up... Ooh, yeah, that was a mistake. What do I do? Ah, okay, fine. HXD. IP bin. Alright, let's look at what's going on here. Sega Saturn, Joe Engine. Well, this is no longer true. Well, I'm not gonna play with this. I'll play with this in SSP and just make a default one and replace it. F. Here. So, this? Is that the only change? That feels too easy. One more spot at the end. Okay. $630. Well, I'm having trouble interpreting any of this, but let me look for the region crap. Produced or under license from... No, it's not. Mine is good. How can you tell? What are you looking at where you can tell me that it's good? Okay, fine. You know what? I'll take your word for it. And if this is the new IP bin that I'll just ship this as the default IP bin, and then no one ever has to think about it again, and they can just play with the ability to use your OS. Let's see if this fixed it. I don't think that did it. Did I not save or no, I saved it. It's saved. Okay, so for the record, we have this argument here, putting it at 06005800. We have the linker script starting at 06005800. I don't know what else needs to change. I mean, I can try inspecting memory to see what's going on while all that stuff is still there. As a sanity check. So here's another block of memory that may or may not be correct, but I don't know if it means anything here. It means it's not working. So here, if I go open this up with 7-zip. What's a different IP? What are you talking about? This is the same IP bin. This is Sgl test IP.bin under common. Here, let me try making another archive. This should be 100% Sgl. There's only the Joe Engine makefile and the compilation program to allow to create the disk. Let me try another one. Barring that, I'm gonna have to try and do like a quick file share. Okay, so I'm trying to upload something to fastupload.io just to share it. And I'm having issues. It doesn't seem to want to work the way I want it to work. Let me try over here. Share, upload. Oh, there we go. Here, try this. It should be good for one day. In the meantime, I'm going to revert the changes so I can keep working on the samples as planned. Okay, so two cubes orbiting each other as they were before. Now, let's figure out what we're actually supposed to be looking at. Okay, stack model. Object group with hierarchical structure. Is this supposed to be representative of our stack? I guess. So you're saying when they shift, okay, so they're just explaining that when you copy, you copy. Okay, that doesn't really seem that useful to me right now. Okay, so... Okay, so they are actually trying to have like a parent-child relationship between two cubes, I guess. Set star. So angle 1, position 1 is our star. That is PD cube. See. Okay, thank you for telling me this useful crap. What about the actual important stuff? Make the current specified matrix a unit matrix. Pop a new one. Distance. R1.SL assign. Oh, the one I found? Okay, let's give it another shot. 58. And over here. 58. Save. Linker script. 58. Save. Run. Hey! Okay. Now, just for sanity, Alt-D, Alt-3, shift over to hierarch RAM, page down, page down, page down, all the way to... You said you want 2F00 cleared out, right? So we still have 2F00 taking up space all the way down to... well, geez, all the way down to here. 3350. Okay, cool. If you want to send it over right now, I can give it a test. Because there's a lot of extra stuff here, but if you want it cleared out to, what was it, like 58? It does appear to be cleared out to 58, where more information is being set up here. Okay, so it's not a tonight thing. Well, I'll keep, because this is currently operating, I will keep it as is. And we'll continue to examine the program that we're examining. So set star, essentially, let's see. This is just a basic translation matrix. So this is just setting up perspective transform to be able to draw something. So set star there, put push, set star, pop. Oh, I see what's going on. So the inheritance is that there is a certain transformation that's being applied to the first cube, which is, well, it's just one cube. They're drawing the same cube twice, which would make lighting difficult, wouldn't it? Wouldn't it mess with the lighting a little bit? Are they lighting? I don't know if they're lighting. But now they're setting the second star, and they're putting down the PD cube, and they're... Okay, so that's drawing it. So this is a perturbation on top of the first one. So the second one is apparently like orbiting the first one. So position 1... it's like orbiting some location somewhere about the x-axis. Position 2 is a distance from position 1. And the angle, well, that's just fixed. Well, they're not lighting it because I don't see SL light. No go rad, mesh off, SPR polygon, no option, no texture, sort min for some reason. Is it a sort center? Their choice, whatever. I don't see anything in the attributes. Okay, well, when we were doing light, so no lighting is no lighting. Which argument would I put here for lighting then? Is it no option? Is that supposed to be my use light? Let me go and look one of my previous oops. Sgl test projects, and we were using light back in 4.5, right? Or something like that. No go rad, because this one also wasn't using. Well, let me double check. No, this one was not being lit either. When was I using light? Or 2 maybe? No, it wasn't that. Three? SL light. Okay, there we go. 3.2. So polygon, we had no go rad, mesh off, SPR data, use light. So use light was being used in place of no option. So let's try that. They're using single plane mode for some reason, even though it's a fully enclosed shape. Now, if my hypothesis is correct, using light will cause a weird lighting direction in terms of, Well, let's apply the light in a way that makes more sense, and also maybe switch up the colors a little bit more. Here, make it a little bit more obvious that colors are being used. Yeah, identical light, but they're being rotated differently, which is the problem I'm trying to display here. So let me copy over some light code. Okay. So I should have pretty consistent lighting, and then after I pop the matrix, I apply the light here. Is that how we do it? Before SL put polygon. I'm not sure if I understand why it's in that specific location, but let's... I'm just going to put it right before SL put polygon, just to see what happens. Okay, it is very hard for me to tell from this perspective, but if the light is coming from the right toward the left, which is what it appears to be, the pink sections on the top seem to be, I don't know, they seem to be having different shades. So this is actually working as intended because I'm recalculating the light per draw. See, the yellow changed colors from the other one. The two blues are different. So the lighting is working. Even with the same instance, the same P data, I get two different lighting effects because I call the light argument twice, once before each draw command. So it seems to be working. I mean, Pona, you would agree, right, Pona? Like, if you do a screen capture and compare two regions of the screen, like the light blue and the dark blue of the two different shapes clearly disagree, which means they're getting two different lighting effects. I mean, that's not the point of this exercise. The point of this exercise is that because we're not popping before we push a new matrix, we're inheriting the transform of the previous matrix, which means if we're doing these nested structures, the transforms, essentially, I think what's eventually going to happen is we're going to get to the Akira model, which is like a skeleton. And you could create a skeleton with different components so that when you rotate your shoulder socket, the rest of your forearm follows, and your hand and fingers, and when you want to move a finger, you only have to move it relative to the hand as opposed to relative to the whole body, which makes calculations a lot more convenient. And Knight just sent me an IP bin, so now we get to do some more of that tomfoolery. Oh boy. Are you kidding? No, first off, why can't I download it? I don't understand. Why can't I download a Discord file from Chrome? Here, I'm going to try and log into Discord on my... my browser, so that I can then attempt to download said file. But Pona, back to the point from previous. I do not think I got identical lighting for the same P data. I think I got two unique lighting effects. I don't know if you agree or not. Okay, so I'm going to shove this here for right now. Knight, if you find me a new IP bin, or is this the one that I want to insert? Bro! Oh, okay, let's run it again, So, you see, I have SL Light calculated here, and then we push the new matrix for the parent-child situation, and then we have the new rotation being applied. We apply the SL Light again before we put put polygon. So if you pay attention to the different color faces. Okay. Well, when you get the new one, I'll try to shove it in. opponent, actually look for this one. So you see the two different shades of yellow, two different shades of... It's harder to see for the magenta, but two different shades of blue and red. And right there, it does look like I'm getting two different shading effects for the same P data. Well, yeah. I mean, you have to calculate it every time you do a transform, right? Like, that makes sense. But it's for the same P data. I was getting a different effect when I was trying to use ZTP to do individualized lighting for instanced entities. And I thought that was because the lighting effect got baked into the entity data somehow. But if it's happening at draw time and it's not being saved as part of the entity, then I thought I remember using SL light. Okay, so this is just a flat white light effect. This is not grow rad shading. But if it's just SL light, at least from what I'm seeing here, you can instance the same P data, draw it multiple times, and get different lighting effects each time, which is great for me. Because that's how I like to arrange game objects, is have multiple calls to the same area in RAM, so I don't have to load the thing 500 times. Okay, fine. It's some form of God, but, Well, that just implies the same thing is going to be happening when I start using colored light with Gurad, is that I can use instanced P data or XP data and apply the lighting effect each time, every time I rotate. So let's say I have a model, and I just array that model around in a circle and have them all face a different direction, but have the same light coming in from, like, the top right or something like that. They should all get lit in apparently different ways, according to their perspective relative to the light. Which is what I wanted, but didn't get when I tried this the first time. Well, I'm happy about that. But yeah, what is being demonstrated is that the next push matrix is inheriting the previous matrix and then putting rotations on top of that, and then when you pop it off, these rotations are undone, you get back to your parent structure. And if you do this and nest it like 100 million times or something like that, you can eventually get like children of children of children, etc., etc., all inheriting rotations, so that you can have things moving relative to other things without having to do hair-pulling matrix mathematics bookkeeping, which is nice. I have no idea what the limit of the matrix. There's a certain size of the matrix stack that you're going to run out of. I just don't know what size that is. Anyway, moving on. So we've done this. I think we've gotten what we're going to get out of it. Load matrix. I use this in Blue Skies, actually. I actually store the matrix in order to use it to draw things. Load and get. But two sides of the same coin. Multiply matrix is just multiplying the stack with whatever matrix you have stored. So this is good for if you want to load a matrix and then you have another matrix you want to apply to it. It's kind of situational, but I think I've used it. So push unit matrix does not do the inheritance. It just pushes a new unit matrix on top, so you don't have to use the parent matrix, which I can see being useful in its own right if you don't need to. If you're trying to do an intermediate draw command and you don't want to lose your inheritance properties, but you also don't want to use it at that moment. SL unit matrix, that just writes a unit matrix to wherever your matrix pointer is. Alright, now here is something interesting. This is an articulated arm with all these weird Japanese style names that I don't understand, but I'm sure they mean things like finger, hand, forearm, bicep, whatever, shoulder. I'm sure this is a good, nice Japanese lesson if I could actually verify that's what this is. Let's go ahead and run it. Demo_B. Alright, so as usual, we gotta fix up some stuff. Let's take our files over from demo A. do some light renaming. Main.c. And fix up our main and the end of our file, and we're good to go. So these fingers are more like helicopter appendages. But it does also appear to be some form of wacky waving inflatable arm flailing tube man. So yeah. So the application here should be pretty obvious, is that if you wanted to construct a model in pieces and have it articulate together, you could use the inheritance to do that. Unfortunately, because of the big gaps you would have between joints, as impressive as it would be technically, it wouldn't really work that well unless you somehow bridged those joints, which would be a lot of work, I would assume. Because you'd have to have an additional draw command just to make some customized connective tissue in terms of making up quads made up of the vertices. Yeah. So the thing is, when you do it like this, you can already see it here. There's an obvious gap that appears when joints start breaking apart, unless they overlap. But when they overlap, you get Z fighting. It's generally better, I would think, to have to get all your animation done in Blender ahead of time, and just play around with interpolation in frames. So, Knight, if what I have set up now is fine, and that's just like junk data taking up that that 2F00 area, whenever you overwrite it, when I load in the binary for your OS, nothing bad should happen, and it should work as intended, is what I'm understanding. Okay. Well, I mean, I'm fine with that. And then whenever Fafling gets done doing whatever he's doing to clean up these Sgl samples for use in tutorials, I will swap in the linker changes and the corrected IP bin, which is just, you know, swapping out the two addresses there. And hopefully that will be a good boilerplate for people to try and bounce off of. I don't know that there's anything I really want to play with here. You see, it's the same concept. It's pushing matrix, so I think we can move on. I keep forgetting to clean up after myself, don't I? Let's see. Yep. The camera. Okay. So I've generally not tried to mess too much with the camera, and I did everything in terms of world space transformations. So I think a lot of the stuff that they're going to do here is going to do a lot of similar things. So by default, the camera should be pointed along Z. And what I generally do is I rotate everything according to that assumption without having the camera move. So the world moves around the camera. The camera does not move through the world. However, I'm guessing that is also valid to do it the other way around. Yeah, so that's what I just described is the first setup, and that's what I use. And I think that's also standard for what everyone else in SX uses, to my knowledge. I don't think anyone does a lot of camera trickery. Because there are certain issues that come up with, like, gimbal lock or something when you play with a camera. I mean, it's not even general relativity. This is Newtonian relativity, but yeah. So you fix the object in place and move the viewpoint in line of sight to obtain the desired image. In order to implement one, necessary to apply modeling transformation to all the objects. Use the library function. So they make it sound like the smart thing to do to save on whatchamacallit, operations is to use SL lookat, but either way, you're applying the matrix operations to the object data. So I don't know that it's necessarily more efficient to do one way or another. It might be easier to program in the second picture, but again, I'm pretty sure there's going to be issues with gimbal lock and stuff like that if you try doing some fancy stuff like looking directly up or turning around or something like that. Oh, okay, so I'm talking ahead. I should just read. Even the cases do, method 1 is used internally and only appears that the camera is moving freely within space. That's exactly what I just said. Okay. I'm just going to keep reading then. More precise camera setup. We use method 1. From the standpoint of processing speed, method 1 is more efficient. Is it? Oh, interesting. Cool. Okay, so I'll keep doing that. Possible to change the viewpoint line of sight. Okay, I'll let the song stay despite the lyrics. So yeah, you can change the way the camera is pointing. So the camera has a line of sight, and it has an up vector, I guess, which is defined by an angle. Yeah, okay. So you got camera location, camera target, that gives you your line of sight. And then the angle basically rotates about that line of sight. But it's hard for me to figure out what the definition of 0 degrees would be. I'm guessing it's yeah, I don't know. Is it just whatever is most pointed toward y negative? I don't know. Okay. So yeah, I guess it's whatever the most sensible way of getting the upward pointed toward y negative would be. But if you actually pointed the camera toward y negative, I think that's when you start getting weird behavior. What do you mean divergence from the direction vector? I mean, no matter what, your camera up is going to be or orthogonal to the direction vector, or the line of sight vector, whatever you want to call it. So that's not optional. That's just how it is. All right, 6-3 camera movement. Let's play around. Okay, there we go. Fix this. Into main. Pile. So presumably this is an example of the camera moving around in space and objects remaining stationary. Honestly, I don't know that there's much I want to play around with in the sample. I'll just examine it just to make sure that I'm saying what is correct. So look at, what is this? What is this structure? What is a CM buff? Camera buff. Camera object. So we have to define the angle of the camera, the target in X and Y, the target in Z, camera position. Okay, so it is a structure, and I'm pretty sure they went over what that structure was, and I just kind of skimmed over it. Or they didn't, and I have to go keep looking somewhere else for it. Or I can just look in the reference. Camera. Oh boy. Come on, give me the structure. Is it case sensitive? There is a camera structure. Do they just define a camera structure? Is that what this is? Oh, there's some cubes. Static camera. So where do they define camera? Is that... Oh, there it is. Ah. Okay, that's why. It's not documented because it's not an official thing. It's just something they made up. Position, target, angle. Okay. Straightforward enough. Figured that out just by looking at this. So we look at from position to target with this induced angle. And does this angle change? It does not appear to change. Or does it? No, it does not. Okay. Angle is 0. Now, let us say that instead of having the target, I don't know, cube position 1. Okay, so they're at Y0, and then... Okay, what's the average of this? 270 to 370, let's call it 320? So let's call it Z... Here, I'm gonna do this. $320. We're going to be looking down from above. So we're going to be looking toward positive 10 from negative 10. Straight down. 320. Let's change the order here so as not to confuse ourselves. We're going to see if we can induce some funky gimbal lock or something like that. Wait, how big are these polygons? Let's see. Minus 10 to 10? Okay, so the camera should probably be at like minus 100. Looking at 100. It doesn't know what to do. Now, is this a consequence of me doing some tomfoolery with this? Huh. Maybe I'm too far away. Maybe instead of 100, I should do like... How far away is this thing? Minus 10. Let's do minus... let's go 30 to... 30 to 0. How about that? Because there should be like 3 things, right? There should be cube positions in... Yeah, various positions. They should be basically lined up. As far as I can tell. Oh, yeah, you know what? I need to be further away than 30 because of my, they're getting clipped. Let's try 50. Okay, am I going crazy or something? Okay, minus 10, right? Let's do 70. By intentionally trying to break it, did I actually break it? Okay. Let's try this. So the cubes seem to be distributed from minus 70 to 40. So let me try going from minus 70 in terms of x to 40. I like how the SGL samples still are like throwing multiple warnings for less than 100 lines of code. There we go. Okay, so with some induced angle, I appear to be able to view things. Let's give myself a little bit more height. 150. Sorry. No, I was doing this wrong. The target needs to be -10, and I need to be at like 100 or something. I was looking at it backwards. Whoops. Maybe higher up to see the rest of it? Okay, so presumably this is me looking from above down at some of these cubes. But I am looking from positive X to negative X. So maybe let's reverse that to make the perspective a little less confusing. Am I going crazy? Oh, 400. Yeah, that should be 40. Doesn't seem like they really changed much at all, but now let's try to move myself a little bit closer or something. Now, here's the thing I don't understand. They're arrayed in, like, a square or something like that. But in terms of screen space, they're in different X positions. They're in different... Okay, so yeah, they're arrayed like that in X and Z. So between -70 and 40, I should be trying to aim for -30. So let me try looking directly down again. Okay, now let's try to perturb this in a way that will allow us to actually see something. So directly down didn't work. What about giving ourselves wiggle room of like 20 degrees? Okay, so that's 20 degrees difference. Let's try 10 degrees difference. So I believe this is the issue that I was running into when I was trying to make a full 3D perspective. And I was first looking at this problem years ago, which is we are just gradually trying to change. Here, let's just do 30 from 31. 1 degree difference. So the image that we're seeing is pretty reasonable, right? It is 4 squares, and we're looking down at them and trying to get to like the center roughly of where they are at, and we got a decent top-down perspective. Like pretend that the roofs of these buildings are pink, right? And this would be like a reasonable top-down perspective, but that's because we've induced just the slightest angle difference. If we just try to make it directly looking straight down, when you look straight down, this is one of the many issues that ended up perturbing the work on Blue Skies. When I look straight down, there's this weird issue here. So you see that purple square in the middle of the screen? That's not normal. That shouldn't be happening. And this is just a difference of like not even 1 degree, 1 unit of view. I actually wonder how little I can make that still make it work. Yeah, there. A difference of 0.0001. Is that enough to induce a difference? See? So when you're trying to look straight down, you throw this weird error where the camera doesn't know where up is. Sgl doesn't know where to force the camera to be up, and it doesn't have like a default to throw to make it work. So I think it just chooses every direction or something, and it just makes it not work. Or whatever matrix math it's doing, it's this weird version of gimbal lock where like everything collapses to a point in the center of the screen. In either case, essentially, if you're going to use the look at picture to try and look at something with the camera, you cannot allow the player to look directly up or down, essentially along the y-axis. This would be perfectly fine for, say, like most first-person shooters or adventure games or whatever. This is me reintroducing the rotation again. But if you have like a space simulation game or a full 3D motion flight game like I've been making, you gotta use different methods for this exact reason. But anyway, if you give yourself a little wiggle room to make it slightly off, then it's still fine. And I guess you could always throw the exception where if delta y is equal to 0, induce it in such a way that up is pointed toward like positive x by adding like integer 1 to a fixed, which is like 1 out of 2 to the 16. Just enough to trick the program into working correctly. That would be a valid way of tricking the program into doing what you want to make it actually work. It just seems unnecessary, or it seems like it shouldn't have to do that. Anyway, that was 6.3. I think I'm done playing with it. I made my point. Wow, what is all this? Okay, so wait, what were we doing? Oh, this is the reference, that's why. Okay, chapter 7. I feel like we've been at it for a long... This is like 3 hours, 20 minutes or so. This feels like a good length of time on a Friday night to stop. I might pick this up again in the near future, or I might just jump directly into my next game. My next game I'm working on is Forsaken Plain. I'll be utilizing the tools that Night of Dragon is using to attempt to get it online. And right now I'm in the process of just getting my Sgl feet wet, or I guess kind of like warming myself back up to be able to handle a big project again. Because I haven't programmed properly in several months on the Saturn. There's more of this homework I need to do, and maybe during the week or something we'll continue to pick this up. Out of curiosity, I'm just gonna scroll, because we started, I think, on page like 32 or something. Where did we really start? Okay, we more or less started on page 34, and we made it all the way up to page 110 in an evening, and we were very distracted doing some other interesting stuff. And if I wanted to get through this whole tutorial, how long is it really? CD-ROM. So a lot of the stuff I don't think I would actually try to mess with too heavily. It's like, here's just how to make save files, which is neat, but not something I would spend a lot of time on stream doing. Sound library. This is something that we're basically replacing with Pone sound, so we wouldn't even do stuff like this. But let's pretend I'm going through everything. Designer's tutorial. Develop 3D software that's... okay, so this is like proprietary or antiquated 3D modeling software that we would no longer be using. So I would say that we went through pages 34 to 110 or so out of 288. So how much of this did we actually get through? Uh, 110 divided minus 34 is going to be 76. We got through like a third of it. I feel like in 1 or 2 more evenings we could pound out the rest of it and like drop all the stuff that's not really relevant to us, because other things have replaced it. Like for say the sound library, unless there's something that nobody's read and I find something interesting, but I don't think it's gonna happen. So yeah, let's pick this up again another night. Thank you everyone for coming on to hang out and help me relearn Sgl properly. So I'm going to go ahead and sign out and say goodnight, everyone.